Hey everybody, this is Larry. This is day 3 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. I'm going to solve this problem live, so let me know what you think. So the explanation may be a little bit tricky, but let's see. Repeated substring pattern. Given a non-empty string, check if we can construct by taking a substring and appending multiple copies of it. Okay, so just like some x substring times y. Okay, and the tricky thing is that n is 10,000, so you cannot do something n square. So I think the most naive thing I would do is just do some n square algorithm, but in 10,000 square it's gonna be a little bit on the big side. Generally, for me, my mental clock is that if n is 1,000 or so, then roughly then I would do n squared, or on some platforms it may be even 2,000. So test that out a little bit, but still within that realm it'll be n squared. So we probably have to think about linear time algorithm. So that's my kind of thought process. Let's see. And I think the thing that always comes to mind, or there are a couple of things. So to be frank, I only know 2 string algorithms, or not, for matching that comes to mind. If it's not the naive library or something like that, one is what is that one? But basically the rolling hash. Man, I'm blanking out the name right now, so I'll put a link below. But then the other one is KMP, which is Knuth Moore Pratt, I think. I hope I get that right. Or Morris, sorry. Knuth Morris Pratt, KMP. So yeah, you'll hear it. Everyone calls it KMP. I'll also put a link on the comments. But yeah, and basically what is the critical thing to learn in that KMP algorithm, and I'm not going to go over it too much because that is beyond the scope of this video. You should, there will be other videos to kind of just learn about the KMP. It's kind of this thing called the prefix function, or the failure function, depending on how you want to call it. But basically, it's a very short piece of code. I will also say that, to be honest, it doesn't really come up that often for me, but I could be wrong. But the question is then, well, how do you use it, right? So given a string, I think you just compare the string to its substring and then kind of go through it to see if you can match some prefix, in this case ABC, such that this prefix matches the entire well, I wouldn't say that this prefix matches the entire thing, but it's just that, okay, let's take a look at the string, for example, right? Well, if we want to match ABC, ABC, then that means that you essentially want to match here, so that means there's some prefix or some suffix of this string and the prefix of this string that matches, and whatever's left over is just the original character, right? And basically that's the strategy that we're going to start with. We're going to start by going from the first character and then just kind of see if they match. And we want to match at least something minus the string minus the first X character or something like that. Yeah, so I'm going to start by, and it's been a little while, so I'm going to do this a little bit slowly because I usually try to do this from memory. And if not, then, it's okay to look these things up because at least for practicing, for observing, because well, you have to learn it somehow, and you're not gonna. It's very hard to derive these by yourself. For me, to be honest, I don't remember. I mean, I remember it, but I try to remember it by principle. But sometimes, especially for this one, because I don't use it that much, there will be times where I'm just missing something really obvious, like that time I had to remove a node from a binary search tree. So okay, so I have so I call it the failure function, but I think it goes by other names as well. Yeah, okay. So basically, let's just start by going n is equal to length. I'm just a little bit teasing that maybe this is not the best name to. I wouldn't do -1. Maybe that's okay. Times n. And then now we start for, well, I guess we need the I, index x in s, enumerate s. And then, so we do j is equal to the failure of index -1 for the previous one. I think I have to start. Oh yeah, no, I think I'm mixing it up a little bit. So we actually do want something like this, but we also want it to start from 1. I Google real quick Python enumerate, because I think you can. I think one of the parameters lets you yes start. So okay, so this is 1. This is correct. So okay. So now again, I'm just implementing the KMP failure function. So, and this is me from memory trying to prove from first principles. And while j is in this case, I guess we could just do 0 maybe, because yeah, and s sub index is not s sub j. Is that right? Then yeah, then j is equal to failure of index -1. I guess technically this is the maybe it's, I don't know. I'm just thinking about notations and whether that's like okay, like that's technically also maybe a parent. Maybe that's a better name. So then now we do fail of index is equal to j, and then that's pretty much it. So let's print out fail just to kind of play around with this, because I actually, to be honest, I don't remember this. This is like, if you want to see a very well prepared video just explaining everything about this problem, there might be other videos for you. But for me, it's just about me discovering the process and how I would go about learning this. You know, as someone who has some idea about it, but just maybe not remember it. Okay. And for me, it's just about a refresher about the failure functions and stuff like that. And for me, for that, it's about visualizing some things again. Sometimes, a lot of times, and when you watch some of my other videos, especially contest videos, I'll have visualizations in my head, or I'll draw some stuff out. But also another way to visualize though is to just print things out and kind of make sure that your mental model of what it is matches what you think it is, so that when you debug things, it'll be clearer later, instead of like, so you could do it step by step, as opposed to like, you know, and if you've done the same problem enough times, like similar problems, not the same problem, hopefully, then you're able to do the visualization in your head, and then you're able to kind of make those leaps. And you know, the secret of, you know, how do you do it so fast is always, I've seen this problem before, right? I don't think there are any tricks about it, or similar problems obviously, or parts of the problem of course. But anyway, so this is as I remembered, which is that, you know, first you match, for this case, first you match the B to the A is no good, so now you move to the C to the A, and this is, yeah, on outside, no good, because basically you're, because we're using the word with itself, right? So yeah, so now that A goes to 1, so the previous match would be to the first index, and so forth for all the other ones, right? So, well, this one is just pointing to the previous case, so this is the last C, right? So in that way, I think that makes sense. You could kind of visualize this failure table as a chain of, like, I always think about these as like a stack that you kind of pop off by going to the parent, kind of, but it's not quite, but that's how I visualize it. And as you can see, as we said before, this failure function matches exactly how we thought about it, which is here, which is that we expect, you know, there's the prefix of thing, right? So then now, how do we get the answer from that? Well, the answer from that is just the first, well, first we have to check that the last number is not 0, because if it's 0, then that means that it didn't match at all, right? So if if fail of n-1 is equal to 0, we return false. And then also the other one is we want to check that the last 0 is so the last 0 will determine the last spot in which we started repeating. So we can just check for that. I guess I should put it in here, but yeah, if j is equal to 0, yeah, 0, then last is equal to max of last index. Though it goes forward, so I know that technically we can just set last equal to index. But so yeah, so now we see that so we get the function, and you can actually just do -1 in Python, but you know, I just want to be a little bit explicit for my whatever. So I guess last will always have a 0 in the first instance, so so we don't have to check for that. So if minus last, so with this mod last is equal to 0, meaning this is this last number is a multiple of these things, then we return, just to keep it consistent, if this is not 0, then we return false. Otherwise we should be able to return true. Yeah, because if this last 0 appears later on, that means that that's not going to be the case anyway, right? I think maybe there's another math that we have to do. Well, clearly, because this returns false for some reason. Wait, let's take a look real quick. Why did that happen? Oh, I messed up, because this should be in last +1, because this is clearly 3, but I have the index of 2, so this is last +1. Oops, oopsie daisy. So you are saying problems that I am not familiar with. That's just why I'm like being deliberate and taking my time. Okay, is that the only case? I feel like I'm missing something. That's why I'm taking a pause. Something feels a little bit. I feel like we have to. So this divided by that is okay, which I guess is fine. Let's play around with more test cases though. And I guess empty. No, it's not empty. Okay. Yeah. So this is the thing that we're worried about. But wait, that doesn't make sense, though, right? Why is last -1? Because that's the only way that it happens. But oh, because I just had assumed that this would look at least the first index, but I forget that I skipped the first index, so I'm just being dumb. Okay. Even though that may be obvious to some of you, I think for me, I just wanted to make sure that I get that. Okay, so let's submit it and see how that goes. Fingers crossed. Taking a long time though. Hope it's not me. This is linear, right? So it should be okay unless I missed a loop somewhere. Oh no. Well, that's unexpected. Let's see. Okay, so this is causing a loop failure, so I probably have some typo somewhere. Oh, this should be the failure of the previous one. So okay, I just have a typo. Wow, I passed a lot of examples, given that was a pretty big typo. Okay, that's actually kind of sad. Maybe I keep on testing stuff that only works. Oh no. Okay. So a lot of issues today. It feels like the last couple of days have been just, but hopefully in the future it'll be a little bit better. Okay, yeah. So this is the one that I was worried about. That's why. Okay. Yeah, I think that was the one that I was worried about and didn't just forgot, which is that we have to make sure this is so. Yeah, so this is a perfect example of how it can kind of degenerate a little bit because we want the length of this to be perfectly the multiple. And I kind of took a shortcut of just taking this and that, but as you can tell, that's not the case. So okay, so basically, if something like n minus, I have to do the math. Think about the math a little bit. If I think this is as well. Maybe I'm off by 1, something like that. Basically, this is saying that from the last item and the last, then but yeah, and it's or maybe just that this should equal to this, one of the two. Oh man, now I messed up a little bit. Well, that's maybe because I have an off by 1. Oh yeah, because I have to do n plus 1, so it, yeah, okay, we subtract that, it'll be n minus 1. Yeah, okay, let's try it again, fingers crossed. Oh man, wow, how am I still alive? I'm making a lot of silly mistakes. Okay. Whew. Did I not print anything? Oh, it. Oh, really? And that is the beauty of doing this live, is that you don't even know what you're gonna get. I thought I had this, to be honest. Okay, so this is, yeah, this is 4. Why is this true? Did I miss this? ABA, ABA. Did I misunderstand this problem? That would be funny though. Oh, is this? Hmm. Oh. Oh. So it's not the last 0 that matters then. So this is a property that I wasn't thinking of. Huh. So this is definitely a multiple of whatever the answer is. But how do we know? I guess if it's distinct, that's how I got the 0 presumption. But I think I've clearly missed some part of understanding this, which is why I'm struggling. But my idea is right, and this one, so because the troubling thing, at least for me, is knowing that like if I do one more thing, then yeah, this will be 10, which going here doesn't really I think I'm missing one property, and I definitely tried to do this thing, but even this is wrong, right? So I think I'm misstating one of the properties, and now I'm trying to think about how to state it in a good way. Well, I mean, I could move that number of spaces, but is that good enough? So I definitely do not understand the failure function as much as I hope. It really doesn't come up that much, that's why, but I don't really know what to make of this failure function. I have to reformulate what I want, right? Okay, let's start from first principles. That's how I kind of think about it. So now we want to, we have this string, and now we want to match that with and then now we have the failure function, and it looks like this, right? Makes sense. It makes sense, but how do I kind of reconstruct this? Or like what is the pattern that I'm trying to think of that yeah, this is not right. Let me get rid of this. So that is right if the pattern doesn't repeat itself, but I guess for this it's not right for sure. I guess this number is just n minus that, and then yeah, okay. I think that makes sense actually. I think I wanted to say something like this, but then I think this is I think what happened was that I mixed these two together in a really poor way. But I think what I actually want is so, and I kind of mentioned this, but let's see if this is good enough. So I have this. That's the number. That's going to give us the prefix, and if this is a multiple of this, yeah. If this is not 0, then return false. Because basically this is saying that the prefix should be a multiple, and this is 5, because this is just 15 minus 10. Then the 10 should be a multiple of whatever the leftover is. So okay, let's run it again. I think I tried to put that idea, but in a really crappy way earlier. Okay, let's try submitting it. Fingers crossed. Okay, cool. Yeah, I mean, not gonna lie, so I definitely struggle with this one because I haven't touched KMP in a long time. I try to avoid it whenever I can, but I probably usually do like I said, I usually do the if I need a string algorithm, I usually use the other one with Robin Corp. But in this case, it seems the most natural for a failure function. But I missed some details about how to interpret the 10, and I thought that the prefix would be good, but that just happens to be, the test cases that I constructed with respect to unique prefixes. But clearly, when it's not unique, then it's not going to be all zeros. Sometimes you do get into a sense of like you look for patterns, and sometimes you find the wrong patterns, and that's okay. Just make sure that you step back a little bit. Make sure that if you have a good understanding of your tools, then you could kind of clear your mind and then start again. And that's what I try to do here with kind of thinking about this. And I think the part that I missed was that maybe it doesn't matter what this number was, and I think I got a little bit too fixated and I didn't clear my mind too much of it. But yeah, so this is KMP. This is linear time because we go through the loop once, and each like you could think about it as I think about it as kind of like a DAG where the failure function just points to the previous index, and each in each case it's gonna it also like in a way it's like a stack, and every time you only go back on that stack once. So and you could do a proof on KMP, but basically this is going to be linear, constant time per element and linear time in total. And then these things, it just requires a good understanding of the failure function and the prefix function, and yeah, because 10 means that you matched the last 10 characters, so that means that the rest is the prefix. And I think I tried to state that, but in a dubious way, and that took me a long time. But yeah, and also obviously linear space. Yeah, that's why for this problem. Let me know what you think. It's a little bit long. It's not my usual. Usually I jump into explanation because I've seen a problem before, but the last couple of ones has been interesting. So hope you enjoyed it as much as I have. Hit the like button and subscribe button. Join me on Discord. Ask me questions about this one. It's a little tricky, and let me know how you did on this problem. I will see y'all tomorrow. Bye bye.